Now here it says if z bar denotes complex conjugate of complex number z in a set of complex numbers, number of distinct roots of this equation are. Now what we'll do is we'll take z bar together and z square together. So we can write z bar into 1 minus I, and it is equal to z square into 1 plus I. What we'll do is we'll multiply both sides with 1 minus iota. So this is z square and it is 1 minus iota square, and it will be z square, and this is 1 plus iota and 1 minus iota. Now this is z bar. Now this is 1 plus iota square. Iota square is minus 1 and then minus 2 iota, and here it is z square, and this is simply 2. Now 1 and 1 will cancel, 2 will cancel, so we'll get z square equals minus iota z bar. Now we'll take z as r into e to the power iota theta. So it will be r square e to the power iota 2 theta, and here it will be minus iota, and z bar is r into e to the power minus iota theta. Now we take mod both sides, we get mod of r square is equal to mod of r, which essentially is either r is 0 or r is 1. Now if we take this first case, when r is 0, one of the solutions is z equals 0. Now for the second case, when r is equal to 1, then mod of z is 1. That means z into z bar is 1. We can write z bar as 1 upon z. So from here we'll get z cube equals minus iota, and this is a cubic polynomial in z, and its root is not equal to z equals to 0. So we'll have additional 3 roots when the value of r is 1. So total number of roots of this equation will be 3 plus 1, and that is simply